All right, 44 gives you a table and you have to complete it. So this is kind of a puzzle. You have to figure out what you know and work backwards sometimes, work forwards, figure out what two things are equal. All right, so here we go. We know we have 8 electrons and 9 neutrons. Now, we know in neutral atoms that protons equals electrons, and then when they become an ion, they change. So we know that if it has 8 electrons, it's going to have 8 protons. And we know if it has 8 protons, the atomic number is 8, because protons equals the atomic number. Then, if the atomic number is 8, we can look on the periodic table and figure out what element it is, and that's going to be oxygen. Okay? All right, now, mass number is the mass of the atom. Remember, mass is protons plus neutrons. Electrons don't weigh anything. So let's take our neutrons and our protons, and let's add them together. We get 17. Then we're going to write our nuclear symbol. This top number is the bigger number, so I'm going to put my big mass number on top and then my atomic number on the bottom. So 17 over 8, and then I put a big O there for oxygen. The isotope name, this number here indicates the mass number. So it's going to be O-17 because it's that particular isotope as opposed to O15, O16, and so forth. And then is this a metal, non-metal, metalloid? Oxygen is on the right side of the periodic table, the right of the zigzag line, so it's a non-metal. So plus it's a gas, so you know it's a non-metal. Okay, magnesium. We know magnesium's got 12 protons because its atomic number 12. And we know if it has 12 positives, it's going to have 12 negatives. And then we know the mass number is equal to protons and neutrons. So add up your protons, which is 12, and your neutrons, 13, and you're going to get a mass of 25. Then let's summarize the information. We know it's magnesium, so we're going to put an Mg there. We're going to put the mass on top, big number on top. If you forget during a test, look around, see if there's an example somewhere. It's always the big number on top of the little number. So the big number is 25, the little number is 12. That's your atomic number. And then isotope name is going to be Mg-25. That tells us which particular magnesium it is. And then magnesium is on the left side of the stair step, so it's a metal. Finally, we've got iron. We've got the nuclear symbol here, and this gives us all the information we need to know. First of all, we know it's iron. It's Fe because of the Latin name. Iron. Then we've got a lower number, an atomic number of 26, and that means that we've got 26 protons. 56 is our mass number, so I'm going to put a 56 there. I know that protons and neutrons together equal my 56. So 26 of those particles, there's 56 inside the nucleus, 26 of those guys are protons. That means 30 are neutrons. And then I also know if I have 26 positives, I'm going to have 26 negatives. Now remember, you all hopefully know that iron's not happy with 26 electrons. It's going to have some extra valence electrons it wants to get rid of, but that's another story. Right now we can assume they're atoms, so we assume they're neutral. Alright, isotope name. We've got Fe-56. We use the mass number. And iron is a metal. Alright, last question in this section. We've got to do the isotope calculation here. It says calculate the average atomic mass for the two isotopes. Now there's two isotopes of chlorine. We got chlorine 35 and chlorine 37. If they were evenly abundant, if chlorine 35 showed up 50% of the time and chlorine 37 showed up 50% of the time, then we do the averages like you were taught when you were a little kid. Add them up, divide by 2, and you would say the average is 36. Unfortunately, the average is not 36 because it's not smack in the middle, because they have different percentages. 35 shows up 75% of the time. 37 shows up only 24% of the time. So the average is not going to be right in the middle here. It's going to be skewed closer to the 35 because it has a higher abundance. So let's do our math, and then we're going to check our answer, make sure it makes sense. Now the formula that you're going to use is the mass, atomic mass, times, or the mass number I should say, times the percentage. Make sure you change the decimal, move the decimal point over 2 points. And then you're going to get a subtotal. Do it again, get a subtotal. If I've given you 8 different isotopes of the same element, you do this 8 times. If I've given you just 2, like in this example, you just do it twice. And then you're going to add them together to get your average atomic mass. Do not divide. That's when you divide by 2 or divide by 8 or divide by however many examples you have, that's assuming they're all evenly abundant, and these are not. So our mass, 35. Our percentage, 75.77, we're going to change that to 0.7577 because we're going to get rid of the percent sign. The next one, 37 times 0.2423. And then we get our subtotals, and our subtotals are 6.52, and down here our subtotal is 8.965, and then we add those two together and we get 35.49, and then we're using AMUs here for a mass, or a unit rather. So this is our average, and then ask yourself, does that make sense to what we first logically thought about? It's not smack in the middle, it's not 36, it's 35, just about 35.5. So it's right about over here, which makes sense. It should be shifted closer to the 35 because it has a higher percentage than the 37. If you ended up with a number that's outside this range, if you got like 32 or you got 40, then you would realize, hopefully, that it doesn't fall within my high and low, so I did something wrong. If it ended up closer to the 37, hopefully little warnings went off and you realized that's also wrong because it has to be closer to the 35 because 35 has a higher percentage. So do the workout and then logically think about your answer. Does it make sense? All right, and that's it for this chapter. Let's move on to light and electron configuration.